All right, guys, so I'm going to talk to you guys today about JavaScript modules. I actually need to unmute this guy. Sorry about the resolution. This projector is a little bit different than the one I plugged into back there. But my name is Merrick Christensen. I work at Domo. I've built lots of high-profile websites and applications for a lot of kind of media companies like National Geographic, ABC, Disney. I'm an open source enthusiast. You'll see me a lot inside of GitHub and Twitter and things like that. And today I'm going to talk to you primarily on RequireJS, and some of the reasons I feel I'm somewhat, competent to speak on that is I created a TypeScript loader for RequireJS. I created a Sweet.js transpiler for RequireJS. I created Squire, which is something to dependency inject with RequireJS so you can test your modules. And as a Use.js contributor before it became Shims in the actual version of RequireJS. So today I'm going to talk primarily on JavaScript modules, AMD and RequireJS, and why RequireJS is amazing and will help you write much more maintainable code. If you want, you can go to github.com and you can follow along with these slides with this URL, or you can also follow along with the example at that require-js-example URL. So what are JavaScript modules? Well, they're distinct pieces of loosely coupled functionality, and they're typically implemented in some sort of a garden environment. In Node, they're first-class citizens, and I'm sure the majority of you have used CommonJS modules. They facilitate the ability to have private variables and export an interface without polluting the global space. They're not exactly new, and this is what JavaScript modules have looked like from kind of the didactic sense. You have some sort of immediately invoked function expression that returns out some sort of API after the function is immediately called. So in this case, private would be a private variable, and some API would consume it. So what is AMD when it comes to these browser modules? Well, CommonJS is excellent. However, to use in the browser, it requires a build to run. And the problem with that is suddenly your errors come from different files, etc. And if you don't, you can synchronously download things, but that would be a poor experience. And so AMD stands for asynchronous module definition because we can asynchronously download all of our modules. It has a plugin system for different types of modules, and this is another one of those wins that I consider over something like a CommonJS solution. You can load in different types of assets. AMD itself is a specification, so it's not RequireJS. RequireJS is an implementation of it, and it has great adoption, better adoption than any other module system in the browser. I would argue. jQuery, MooTools, Milk, which is a newer project from MooTools. I hope they keep trekking on. Dojo, Firebug, and lots more. So RequireJS, like I said, is the reference implementation for AMD. If you want to know how AMD is supposed to work, you will check out RequireJS. It installs two methods on your browser, a require function and a define function. And again, it's just an implementation for the specification. There are other implementations like curl.js. LinkedIn now has one. There's one called Cajun. There's a Node one, etc. So what would an initial page look like if you're using RequireJS? It's just an HTML document where you're referencing the script require, and that'll go ahead and install those two methods, require and define. So what does define look like and what does it do? Well, it's used to define a module, and you specify all of your dependencies, and you can optionally name your module. And I say optionally because you typically shouldn't name your modules. That's what the build tool will do for you. The modules are loaded by path. So if you put my/module, it will go to your base URL, find a folder called my, and then find a file called module.js, and it'll download it on the page for you. So if you name it, then you're going to have problems with that, and the build will name it for you. And then you export your module interface. So this is what the define API looks like if you name your module. This first argument is name. These are your lists of dependencies, so by the path convention. Dependency will be downloaded in this case, bar will be downloaded, and then your module definition function will be called with dependency and bar. When we export out win and lose, in which case somebody could consume this module and just call win and lose, not knowing that I'm actually speaking with sub-dependencies. If we weren't to name it, you can just omit that first argument, have your two dependencies and your module definition the same. And the dependencies are actually optional as well if you don't have any dependencies for a module. You can just pass in your module definition function and export out your interface. So for our app.main, we have some sort of HTML body that we're going to set in the document. And we're going to export some start method. So someone will require app/main, and then they'll call start on that, and it'll set the body to hello world. So what is the require function that it installs? It's used to load top-level JavaScript. It's kind of like an entry point. If you're familiar with like a main method in C or Java, you typically use require to kick off your app, to load the initial code. It doesn't define a module, but it can load modules and give a callback in the same way that define does. And it's also used to lazily load code, which is another one of the biggest wins of just not concatenating your scripts. Concatenating your scripts just doesn't scale very well when you need to start doing sophisticated builds. So require API looks like this. Same as define, except for you don't name it because it's not a module. You just say, I'm requiring foo, I'm going to get foo in my callback, and I'm going to execute foo.win. Or with multiple dependencies, this will download foo and bar asynchronously, and then it will execute the callback once they're both loaded. So how would we lazily load code? Well, RequireJS offers this sort of magic module name called require that we can take into an argument, and it gives us the ability to require within a define. So take the case of Gmail. You have this really sophisticated application, and a huge majority of the time users aren't going to interact with the chat functionality. So should they have to download the chat? Probably not. You may want to lazily download it later. So in this case, we're going to download jQuery as a dependency. We're going to register some sort of click on some anchor with a chat-start, and then we're going to download features/chat when they click to interact with the chat, and that'll download all of the chat dependencies, and we'll call chat.start, which will start up the chat functionality. One other thing about the RequireJS, the require method, is if you call require.config, it'll actually load back a multiple context loader. So you can have multiple contexts, multiple loaders. So what would our main.js look like for that app that we're talking about? We would require app/main when we get app, and we call app.start, and then that would set the HTML body to hello world. Luckily, we don't have to put that in a script tag. In fact, we can just put this data-main attribute onto the RequireJS script, and it'll actually trace this as our entry point for our module. So it'll go download main.js, which will then require app/main, and then it'll start our app up. So the hello world example isn't exactly very interesting. There's not really any dependencies to it, so let's look at adding maybe like handlebars. So RequireJS lets you configure the loader in really sophisticated ways, and as well as the plugins that RequireJS provides. So if we wanted to, for example, change the paths, in this case, when somebody requires underscore, they'll get back Lodash. I knew Jonathan David Dolan was here, so I had to put that in there. Shims, for example. What if the code doesn't support AMD? What if there's no define inside of the code? Well, you can just say when they require backbone, the dependencies you need are underscore and jQuery, and then it exports this backbone variable. So it gives you the ability to basically shim AMD support onto libraries that don't support it natively. And this tends to be really, really useful in the case of people who don't want to support AMD. And then maps. I don't know if any of you guys have worked on a giant code base and you want to refactor to some newer version of a library, but there's API breaking changes. And it's just miserable because you don't want to do that. Like, you don't like it. So in this case, when some module requires foo, it'll get foo 1.2. However, when some old module requires foo, it'll get foo 1.0. So you can slowly refactor your app, and you can go, all the dependencies from this older version of foo 1.0 are slowly going to start getting foo 1.2, and then eventually you can take out foo 1.0 and have a slow refactoring path and not go silent for months or however long it would take you to replace certain dependencies. So what would our main.js look like with this configuration? We would alias handlebars to the handlebars file. We would shim handlebars, and we would export the handlebars variable, download our app, and kick it off. Okay, so now that we're done with the kind of boring rudimentary stuff, this is going to get cooler. RequireAirbacks. So airbags give you a chance to catch module loading failure or your own script errors. So the problem with JavaScript is, and well, I shouldn't say it's a problem because a lot of people are really sensitive about this. There's no types, so you can't be quite sure that your code's not going to throw certain errors in certain random states, right? So not only can you necessarily check if an error fails from loading, but you can also watch your own script errors and handle them gracefully. This is a case where if the CDN of jQuery goes down, we're going to go ahead and we're going to pass this third parameter. This third parameter into the require statement lets us catch the error, figure out that jQuery was the one that failed, undefine the module, change it to a local version of jQuery, and then restart our app accordingly. Yes, thank you. So this is a common enough use case, actually. Basically, I want to use the CDN for cache, but if the CDN's down, I don't want to be brought to my knees. That RequireJS actually lets you just pass an array into the paths for a key. And then in order of that array is how we'll try and download them. So if it can't download jQuery from the CDN, it'll fall back to your local version of jQuery, which is amazing because CDNs do go down, unfortunately. And this is where it gets really cool. With your own app errors, right? So you require chat, you start chat up, and then your airback basically listens for chat errors, right? So for some reason the user gets it in some sort of odd state, and normally when JavaScript throws an exception, it just stops executing beneath that, right? So then your app just suddenly like freezes, and unfortunately, maybe fortunately actually, users are trained to just refresh the browser when something's not working. They're like, it doesn't work, screw this, I'm gonna refresh it. But I think that's kind of sad, actually. I think it's a representation on our inability to gracefully watch our errors. So in this case, we can see that chat broke our hearts, it failed. We can require some sort of logging module, log off to some service or to our developers and be like, hey, we're getting errors in this browser, on this line, etc. And then you can actually restart the chat application in the case that they broke it in some odd chat. So they can still be checking their emails even though you had some sort of script error, and you can gracefully shut down and restart certain pieces of your application. So what would main.js look like? I wanted to do a live example for you guys, by the way, and you can see it on GitHub, but there just wasn't enough time. But I actually wrote kind of a JavaScript chaos monkey that throws an error a certain percentage of the time, and you can actually see it restart the app. So in this case, an error gets thrown inside of app.main 80% of the time. This is what the chaos monkey looks like. Just calls chaos, and 80% or 20% of the time it'll just throw chaos monkey strikes, and then your app has to respond gracefully. So using RequireJS plugins. How many of you guys have used Node.js, by the way? Oh, that's such a beautiful site. Like JavaScript. Oh man, this is awesome. So you guys are probably familiar with middleware, like in the sense of Connect, right? Require plugins are kind of like middleware for your browser scripts. You can pre-process your code or change your loading strategy. And it basically just tiers through your plugins until you actually execute your code. So this means that we can load different kinds of assets. We can load text files. We can load CoffeeScript files and have them compiled in the browser. And that's actually what Require Suite and Require TypeScript do, is they compile these things in the browser. And the cool thing is these plugins actually can implement a build-write strategy, and you can write out different things for the build. So you're not always compiling in the fly on the browser. That's only for development. In the write, you can actually just print out the compiled JavaScript, right? There's tons of plugins. CoffeeScript, JSON. You require a JSON file, and it'll be parsed, JSON.parsed for you, etc. This is great for removing boilerplate. So what does it look like? Well, fortunately, these modules are plugins are actually, they're just RequireJS modules that implement a certain API. So foo just happens to be a require module, and it implements an API that bar will be passed through before you accept bar. So for example, this would download module.coffee, and would get some CoffeeScript text, compile it for you, and then it would pass it to you in the callback already compiled. So here we're interacting with CoffeeScript from JavaScript without ever running the CLI, right? Without ever running CoffeeScript compiler locally. A more common use case, I want to download my template.handlebars, but I just wanted it as a string. So give me the string of this template rather than making me embed it in script tags or in JavaScript or whatever the heck. That's all really gross and weird. So give me the string, and I'm just going to pass it into handlebars and compile it. And yeah, so this is how we would add the text plugin. So we don't want to reference it in vendor.text. We just alias text. We factor out that piece of our application that was hello world into a separate template. And then where what once was HTML inside of our markup, we're actually just compiling it right there after loading in the text. And then we're just calling hello CascadiaJS on that guy. So I want to talk a little bit about the making and admiring of RequireJS plugins. What does it look like to make a RequireJS plugin? And What are some of the cooler ones that people have done? Again, plugins are kind of like middleware. You can significantly reduce the boilerplate of your application by, JSON.parse. Why would you have to run that if you know you're getting to get JSON? You just say JSON bang and then specify your JSON resource. And like I said, plugins can actually write different things to the build, which means while you're compiling your handlebars templates in the browser for development, because you want the errors accordingly, you can actually pre-compile them in the build and just put the pre-compiled templates to disk before you ship. So they're just modules. Load actually happens to be the only required function, the only required method that you have to implement. It takes a name, the parent require instance, a load callback, and then some configuration, because people can configure your plugins accordingly. So here we're using parent require to download the module, and we're adding an extra function to it called extra. So now anyone that goes plugin, bang, and then whatever their module is, it doesn't matter, they can call module.extra. So they get this .extra thing appended to them by the plugin. Does that make sense? I hope. Plugins can implement a custom load strategy. So this is a case, this is a Vue plugin. It's theoretical, but I actually think there's one called Feature that does this or something similar to it. When you say view navigation view, figure out what device you're asking me to give this resource to you on, or what device I'm building for, and then I'm going to give you a different view based on that device. So long as the views implement a different API or the same API, it doesn't matter if you're giving me back a mobile view, an Android view, it doesn't matter how specific you get, the loader can actually decide the right resource. And by the time you're actually working with it, it doesn't really matter to you what device you're on. So a lot of people look at AMD and they're like, oh, but man, you're lazily loading all these scripts, and the hardest part about that is it's just not true. Yeah, you do that in development, and in my opinion, you should do that in development because you shouldn't need a build step for development, first off. That's not how the web started, and I think it's beautiful that you can just refresh the page and get your feedback immediately. It's a very fast feedback loop. And not only that, but you also get all of these plugins, and your build can be highly sophisticated. You can concatenate and minify sub pieces of your application, the entire application. You can get very fine-grained and detailed with how you're built. So how does it work? Well, it's a node CLI. It traces all of your dependencies. It concatenates and uglifies through modules. And it will name the unnamed modules. Remember I said the name parameter is optional? You don't want to do that because you don't want to name them because that's what the build tool will do for you. It'll name them based on how it finds them. Plugins are supported, like I said, so text templates will actually be inlined into your JavaScript. So before you're getting this string passed to you, now it'll actually be an inline string. And if you're one-filing, you don't even have to have RequireJS on the page. You could strip out RequireJS and define calls and just have them be regular JavaScript globals, or you could even use like a shim like Almond, and you can ask me more about that if you care. This is an example of leveraging a plugin at build time, pre-compiling a template. Also, you can run through Google Closure Compiler or Uglify.js, which is absolutely amazing. The Google Closure project is just a brilliant work of engineering. In which case, you can do dead code stripping. So all of the kind of things you'd expect from a build. So for our app, if I point to our main configuration file, which I think you guys remember, it had the paths with handlebars and had a shim. Then we had our app named app/main, and then we had an out, main.built, and we run this on the command line with r.js, and then we pass it our configuration file, and we let it do its magic. So here, it went through app/main, it found handlebars, it found our chaos monkey, it found the text plugin, it found the string template, and it found our main, and it built it all into one file, and it minified it. So some other interesting work you guys could look at is Xray Acquire. I don't know if you guys are using RequireJS already, but if you haven't looked at Xray Acquire, it's really interesting because it actually gives you more insight. You put it on, it's an auxiliary script, and you put it on your page, and you can actually see more information about how your modules are depending on each other, which tends to be pretty interesting if you got a big team that are writing a lot of JavaScript modules. RequireHM, and I don't know if any of you guys are using Yeoman or have looked at Yeoman, but they claim to have some sort of Harmony support, and so far as I know, they're actually just using RequireHM. This lets you, because modules are such a key component to JavaScript, in ECMAScript 6, I think, the next version of JavaScript, they actually do have some specifications for modules that they're working on that I've seen. It looks kind of like the Python module system, but what RequireHM lets you do is load sort of a subset of those APIs into your browser just by using the pre-processing stuff that you saw with like CoffeeScript. And then if you can't bring yourself to write the define and require boilerplate, there's also the Cajun loader, which will let you load in common JS modules into the browser, but it comes with a cost. So thank you guys so much. It's been an honor to speak to you. Yeah, I appreciate you guys.